write the expression for Kc. So Kc equals concentration of the products divided by concentration of the reactants. So it'll be NO2 all squared divided by NO squared times O2. Remember, when the stoichiometric number is greater than 1, for example, that number, you raise it as a power for the concentration of that particular reactant or product. So now that we've got the expression for Kc, the next thing to do is to substitute in the units. Now the units for concentration are always the same. It's always moles per decimeter cubed. So that's what I'm going to do. So on the top we have moles per dm cubed, and because it's squared, it's times another moles per dm cubed, all divided by moles per dm cubed times moles per dm cubed times another moles per dm cubed. And you will see I've deliberately written it out the long way. So rather than square the moles and square the dm-3, I've just written it out the long way. And the reason why is it's just slightly easier to see when you're cancelling down things that are common to the top and the bottom. With that said, I can cancel this with this and this with this, which now takes me to 1 over moles per dm cubed. Now, you can leave it like that, but it's good practice to express the units on the top line. So just something from maths first of all. So you may remember from indices that if you have, for example, a term on the bottom in a fraction, so the denominator, when that term goes to the top, the sign of the indice changes. So that would become 1 times a to the minus 2, or in other words, a to the minus 2. The reason why I mention this is because I have to apply that to the units on the bottom. So we have the moles bit, and then separately we have the dm part as well. So what you got to remember, there's actually a 1 there. If I put it in blue just to make that stand out, there's actually a 1 there. So moles to the power of 1. You know, when things are to the power of 1, you often just leave the 1 out, but technically it is there. So we need to remember that, because when we bring that to the top now, this is what happens. So we have moles goes to the top and becomes moles the -1, and then the dm-3 changes to dm+3. So we can write that with a positive unit first, dm3 moles -1, and that is the final answer for the units for Kc in this particular reaction. Right, for the next bit, what happens if we were asked to do the expression for Kp instead? So instead of concentrations, it's in terms of partial pressures. The expression for Kp for the same reaction, if I just scroll back up, you can see it'll be, usually the notation is to do a capital P, standing for partial pressure, and then subscript the reagents will be NO2, and that's all squared, all divided by the partial pressure of the NO, and that's squared, times the partial pressure of O2. Now, it depends on the question what the unit of pressure would be. Usually it's either in Pascal or atmospheres. So just for today, let's just say that the pressure unit is given to us as atmospheres. And therefore, that is what we need to substitute into this expression. So we end up with Kp equals atmospheres times atmospheres divided by atmospheres times another atmospheres, and again. And then we have the same situation where we can cancel out common terms on the top and the bottom. So that with that, that with that, leaving us with ATM. And then that can be taken to the top. It becomes ATM to the -1. So that would be the unit for Kp for this particular reaction. So I hope that was helpful today. And if you had any value, please subscribe, and I will see you in the next one.